here. So I'm starting to stream now. Okay, so I was a little too excited to get started and then I forgot to flip the switches. All right, so let's see. Should we go over some of the questions in the announcement? Yes. Okay. I'm guessing those thumbs up are for some of those thumbs up are for the announcements, for going over the items in the announcement. So I'm gonna click on weekend review. And for those of you who say, but I know all of this stuff already, I have the best study skill ever and I don't need this. Don't worry, this is the only week, where I would kind of post some reminders just so that people know that, well, this can be beneficial. All right. And okay, so this one doesn't have any questions. I'm going to go back to the previous one, which has a few items in it. So a few recaps. There we go. All right, so let's go through these items one by one. What do you know about implication, which is this A and then a double bar arrow to the right hand side? Any questions about implication? What is the truth table of implication? Now we talked about that in class. It's not in the module itself, but we did talk about it in class. And I believe I posted the HTML version of the notes of that day. How do you read a truth table? What is a row of a truth table representing? How is implication defined by a truth table? Okay, so once again, we kind of get back to the truth table that we talked about 4 days ago. Okay, so this is what I do not like about Monday, Wednesday, and then Tuesday, Thursday classes, because we used to have, when I was in college, we used to have Monday, Wednesday, Friday classes, and I really like those classes because they kind of spread the topics out a little bit better. But we don't have those classes anymore, at least not in computer science. All right, the next question is even more interesting because I think Chris was the one who put up this alternative definition of implication. So A implies B can also be expressed as A question mark B colon 1. Now this is a ternary expression. I talked about that on last Wednesday. So I'm hoping people who are not familiar with the ternary expression did look it up and find out how this ternary expression is really doing the same thing as A implies B. So if you have not looked it up or thought about this a little bit, I kind of encourage you to do that. It's a very inventive way, creative way to express implication, but it works. It does work the same way as the original implication operator. All right, so what is De Morgan's law? How is De Morgan's law used in the lecture on last Thursday? So that's one more thing. We did talk about De Morgan's law. So the question is, how do we apply that in the class on Wednesday? And then what are the alternative way to express conjunction, disjunction, and negation? And that's relating to NAND, N-A-N-D. So that's kind of where we stopped. Okay, we talked about equivalent, which is the double-sided arrow with 2 bars. So that's where we stopped. All right, so the last paragraph here talks about how to read ahead of the class, how you can kind of jot down some notes, as you read through the material, collect the definitions into one place, do some summaries, and also write down any questions you might have about the material, because I think that's really important that you read a little bit ahead of time and kind of have some idea of what we are going to talk about. So the analogy is kind of like painting. Okay, so if you ask any professional painter, especially painting on cars and metallic objects, they don't just put paint on the object, right? They have to prime it first. So there's a primer. So the job of the primer is it bonds to the metal on one side and then it bonds to the paint on the other side. So reading ahead of time is kind of like applying that primer in your mind so that the ideas and the concepts, the definitions, the symbols, they stick better, once you have the primer in your mind. All right, so I'm not gonna nag, a whole lot more about, study skills and whatnot, but I do think that it is important to at least mention it once, in the class. Cool. All right, so now we're gonna move on to talk about, the concept of a set and the notations, basically revolving around the set concept. So if I need to put it simply, a set is a containment of elements. Now the best way to think about a set is you can look at it as a folder. It's a container. A folder, as in a file system, is a container too, because you can contain other folders within it. You can also contain files within it. So the concept of a set is kind of like the concept of a folder. The most basic concept of set theory is the concept of a set containing or not containing a particular element. So the question is, what exactly is an element? Well, to put simply, an element is a thing that can be a part of a set, or it may not be a part of a set. Now, that's not really saying a whole lot, right? But that's the idea of membership. Okay, you can point at one thing which can be a set, by itself, and then you can ask, is that thing a member of that set over there? The answer is either yes or no, right? And that really is the core of the concept of a set. An element can be just about anything that can establish uniqueness. In other words, if you look at two elements, you kind of need to have a well-defined operator to say, are these two the same thing? Okay, because you need to be able to tell whether an element is the same as another element or not. Alright, so there's a question in the text channel. It's kind of like a file in or out of a folder. Yeah, it's kind of like that. Or it can be a folder itself, whether it's in another folder or not. So yes, so that would be a good analogy. In other words, I'm just looking, oh, okay, my face is covering some of the text already. There we go. Alright, so in other words, given two values that may be elements, we need to be able to compare and see if they are the same value or not. So comparing to identify whether two things are really the same or not is important when we are talking about the set of the concept of a set. Note that ordering is not needed for of values that can be elements. So that means there's no need to be able to differentiate. Is this less than the other one? Nah, we don't need it. Okay, we just need to know whether equal or not equal. Okay, less than, greater than, less than or equal to, greater than or equal to. Those are not needed. Okay, now it's not saying that those are not useful. Okay, it is going to be useful later on when we talk about relations. But when we're only talking about the concept of a set, ordering is not important. So this means there's no need to determine what value is greater. Just knowing whether a value is the same as another value is sufficient. So another thing about a set, or how elements can be contained in a set, is you cannot have duplicate items. Okay, just like you cannot have duplicate files. Okay, the files inside a folder, no two files can have the same name. There's no copies. You either have a file in a folder or it's not in a folder, but you cannot have two files of the same name in one folder. So that is also something that you can easily relate to folders, right? Because if you try to create two individual files and they have the same file name, it's not going to work, right? The later file is going to overwrite the original file, but you end up with only one file of a specific name in a folder. Well, okay, so that is in an ordinary case of a folder, because if you do this in Google Drive is kind of weird in the sense that it does allow you to have multiple cortical files of the same name. And then we move on to talk about the last important concept of a set is that elements in a set must be unique. We kind of talked about it already, which means the same value cannot be represented more than once in a set. So no duplicate items. You have to be able to, so in order to determine whether two things are duplicates of each other or not, that really kind of goes back to the ability to tell whether two things are the same or not. So that's why we're running a little bit in a circle, with these statements over here. So we're going to introduce some symbols. Typically, though not required, a set is represented by an uppercase letter. Not all the time, but most of the time I would use an uppercase letter to, as a variable where the type is a set. And the elements inside a set are enclosed by braces, just like a block in C and C++. And I'm going to go back to the text channel after I finish this sentence. For example, the following is a set of a few members. So the set T is the name of a variable. The variable is a set. And then the membership of the set, in other words, what is in the set T, would include the value of 12, 5, 2.2, 7, -1, and 10. Now, if you change these ordering, as long as everything is still here, that's perfectly okay. There's no inherent ordering of elements within a set. So I'm going to switch to the text channel right now. And it says content versus file name. How do they come in play here? We only care about file name. There's no content, to talk about if you're only talking about the uniqueness, of a set. So when we are talking about, a folder within another folder, that gets a little bit tricky. So we'll talk about that later. Alright, so using this as an example, we can illustrate the use of the element of operator. So the element of operator is this operator here. It looks like an uppercase E, but except without the square, the right angle top and bottom corners, and instead it's rounded. And you can, if you want to pronounce, okay, when you see this symbol here, the one that is under my mouse cursor, you can pronounce it, or you can say it as in. So that's the quickest and easiest way to say it. Okay, you can also say is an element of. So in this case, 2.2 is an element of T. Is not an assertion. Okay, it's not saying that 2.2 should be in T. It is asking a question of whether 2.2 is in T. So as an expression, 2.2 in T is true. Okay, it gives you a Boolean value because it can either be true or false. On the other hand, 23 in T is false because when you look at the definition of T in this specific case, 23 is not one of its elements. So I'm going to pause here and see if there are any questions before we move on to section 2.1. I'm just looking at the, yeah, go ahead. Yep, it's asking whether 2.2 is in T or not. Yep, it is just asking a question. It's no more than asking a question as when you read x is less than y in a program. Is really a Boolean, right? X is less than y can be true if x is indeed having a value that is less than y, or it can be false when the value of x is not less than y. So it's the same thing over here. It is really asking a question of whether that is the case or not. Now, in some contexts, it can be an assertion, so we'll talk about that when we see it. But in general, it is just an operator, which means it is it's a component in an expression, and then the expression has a value of either true or false. And then Philip is asking, so a set is like an array or vector of elements. Sort of. Okay. A vector is order dependent. In other words, if you have a vector of values 1, 2, and then you have another vector of the value 2, 1, those two vectors are considered distinct. They are not the same. But in the case of a set, how you list the values within the braces is irrelevant. So if you say, okay, let me just give you an example. I think it's probably a better thing for me to illustrate with an example. So let me get. Oh, okay. It's a different tab. I keep switching between the windows, but it's actually really just a tab. And I need to go back to my markdown editing here. All right. So I used to use Joplin to take notes or to express my notes in class, but now I'm kind of stepping away from that because I find this is better. It's less distracting because you don't have to see how I'm typing the markdown side, and you can just focus on what is rendered. So that's probably better. All right, so let me try to remember what concept I was about to illustrate. Oh, right. Okay, which two sets are considered the same? All right, so here we go. So if you have a set, that lists its elements as 1, 2, and then you have another set that lists the elements as 2, 1, those two are the same. So when you look at this particular equality, this equality is indeed true. Do we have any questions about this specific example? All right. So this is illustrating that the fact that ordering, inside the curly braces, which is basically, this is how we say, okay, what is in between the braces are the elements of a set. So these two sets are considered exactly the same, okay? Because 1, 2, 2, 1, hey, the ordering does not matter in this case. Are we good so far with this? All right. All right, and then Chris put something here. You could make elements of a C, C++, just like greater than or less than. Well, C or C++ does not actually have a built-in type of set, so it naturally does not have an operator, relating to set operations. Some of the other languages has, quote-unquote built-in types like a set. I believe JavaScript has a built-in type, it's a class, but you can basically say, okay, here is a set object, and then you can use certain methods with a set, and you can check whether an element is in a set or not. But the implementation of a set in JavaScript is very, very limited. Okay, the way it can identify whether two elements are the same or not is very primitive. So it's not quite ready for the expression of a lot of algorithms, I would say. You will have to extend it a little bit before it is usable in the expression of algorithms that make use of the concept of a set. All right, so with that said, let me see if there are any other things that I can illustrate here. Okay, so the element of is already demonstrated here is either true or false. So not much that I need to say at this point about set, its elements, and the element of operator. And then food for thought is, how would you implement the concept of a set in C or C++? So in my mind, okay, C is really more or less mostly a subset of C++. There are certain things you can do in C, but you cannot do it in C++, and vice versa. The vice versa part is not a problem. It's certain things that you can do in C that you cannot do in C++. That makes it not exactly a subset. No pun intended, because we're going to talk about what a subset really is in the context of this particular module. Compare arrays and vectors. That would be certain things that's something you can do in C++, but you cannot do it in C, which is okay, because there are tons of things you can do in C++ that you cannot do in C. In other words, for the most part, C is a subset of C++. But it's not entirely a subset, because certain things you can do in C that you cannot do in C++. So that makes it it's a little bit tricky when you get to those specific items. But it's not a whole lot. There are very, very few things that you can do in C, but you cannot do in C++. If you know ahead of time a set to only contain integer values, how would you implement a set? How do you check whether a value is an element of a set, and how do you place elements into a set? So that sounds pretty theoretical. It's like, who would need the representation of a set in a program that is written in C? Okay, let's not even mention C++ because C is a whole lot lower level compared to C++. Well, the answer is actually quite interesting. There are some really interesting and low level. When I say low level, that means it's really close to the operating system. There are some of these services or APIs that actually depend on the concept of a set. And as a result, this particular food for thought is not exactly theoretical. It's not really a theoretical exercise. It's actually kind of something that you might want to think about, at least for smaller integer values, like, if you have to go from 0 to 255 as potential elements, what would be a way to represent a set? Okay, so I'm not going to talk about the solution at this point, but I would like you to kind of give it some thoughts, just think about it a little bit. All right, so any questions? All right, cool. No questions. So section 3 is interesting because it is expanding on the concept of how do we compare two sets. Okay, so how do we establish whether two sets are the same or not? So let me go ahead and read the definition. A set can be compared to another set to see if they are the same. At this point, we lack the precise mathematical notation for this kind of discussion, but we can still utilize English for the most part. Let's say we are interested in whether set S and set T are the same. The two sets are considered the same when every element in S is found in T and every element of T in T is found in S. If this requirement is satisfied, then S and T are the same would be true. Alright, so this is all kind of not too difficult to grasp. The next one is a little bit more interesting. So section 4 talks about how a set can be an element of another set. And I think Mohammed would be the person, because just judging from the concepts that he had typed in the text channel, I think he would be going like, but it's just like a folder can be another folder. And the answer would be exactly, okay? Because you can look at a set as a folder, so now you can say, oh, okay, so a folder can contain additional folders. So now the question is, can we do a quote-unquote recursive comparison between two folders and see if they are truly equivalent or not? But before we go there, okay, there's one interesting, actually I'm going to talk about it later, so let's not worry about that for now. Alright, so now I'm going to type, in the preview, I'm typing two things. Okay, let me switch to the notes here. So I'm going to give you a set here that looks kind of interesting. So it has a member A1, and it has another member that is a set that has 1 as a member. And just, to make it even more confusing, let's also contain that as an element. So now, if I just want to look at this particular set here, okay, my mic is having some issues. I'm gonna have to fix that really soon. Well, that's kind of one way to look at it. But to look at this, you can kind of look at this as a folder. At the top level of this folder, we actually have 3 items. The first item is a regular file. It is called 1. So remember, we cannot really look at the content of a file. We can only look at the name of a file. The second one is a folder that contains 1 as a file. The third one is a folder that contains another folder, and then it contains a file called 1. Now, can you construct, a file structure or folder structure like this? Absolutely, right? I mean, you can just create a folder, and within the folder you say, okay, I'm creating a file called 1, and then I'm going to create a subfolder which also contains a file called 1, and then I'm creating another subfolder that contains a subfolder and it contains a file called 1. So Do we have any questions about this? Okay, if we don't have any questions about this, let's talk about membership in just using this example. Yeah, I have to kind of play with my mic cable a little bit here because I think with certain tension at certain places, the ground conductor is disconnecting. I have to find out, because I yanked my mic a little too hard one time. I forgot to take it off before I started to walk away from my station. So I think somewhere there's an internal breakage. Internal. It's not a short. It is the other one. It's an internal open circuit, and that's the hardest to find. Is to find out where is it breaking. Yeah, I think wireless. I think we like wireless stuff for a reason, right? So that we don't have this problem. I already got a wireless, headset, picked out. Just didn't. I just don't want to spend the money yet. All right. So with the second example, I am going to take out two of the elements. So now we only get one element here. Yeah, it is. It's not degrading. It's me doing the damage. All right. So let's go ahead and ask this question. Okay, is 1 a value in this particular set? So I want to is true or false? What is it? The answer is no, it is false. Okay, so Chris is correct. It is false because the one element, okay, if you look at the set, it has one element, but the element that it does contain is not even a number, it's not even a numerical value, it is a set on its own. And the value that I'm trying to check to see if it is an element of this particular set or not, is a numerical value. So if you just look at it from the perspective of type matching, it doesn't even match. Okay, we're looking at two things. Okay, the one thing on the outside we want to check for membership does not even have the same type as the only element in the set. It's more like a folder because this is a folder, and the only thing that is contained within the folder we are looking at is a subfolder. So we are asking whether a file is the same as a subfolder, and the answer is always no because they are not even of the same type. All right. So now we're gonna take a look at another example. I keep trying to copy the line from the wrong window. So now we're gonna look at this one. There we go. So how about this one? Is the answer true or false? Yep, the answer is true this time. Okay, I really should not be using a question mark here because we know that is the answer. All right, so one more time. Okay, so this time we're gonna have, there we go. What about this one? Is the answer true or false? Okay, very good. This is false indeed. All right, and just for kakas, I'm going to change the operator to a equality. And what would be the answer to this particular question? Yep. All right, that is correct. All right, so I think I'm illustrating, the concept of, how a set can be an element of another set, and how we can determine membership in those cases. All right, so maybe one more, okay? Just one more. Just one more. So let's see. This time we got the set of 1, 2, and we want to see if this is in another set that has 1, 2, 3 in it. And let me put a $ sign here. So how about this one? Is it true or false? Alright, so let me answer the question in the text channel. Will we use the equivalence symbol in situations like that? No, it's equality. It's not equivalence, it is equality. Equivalence works when both sides are Boolean. So if one side is true, the other side has to be true, and if one side is false, the other side has to be false. Then we use equivalence, which is the double bar with two arrows on both ends. But since this one is actually just comparing to see if two values are the same, it is just using equality in this case. All right. So the answer to this question is false. It is not true because 1, 2 in a set and 1, 2, 3 in a set are two different things. Okay, so I'm going to say because. Okay, so because, and this time I'm going to use the set 1, 2 equals to the set that contains 1, 2, and 3 in it, because this is false. Are we doing okay so far? The set that contains 1, 2 and the set that contains 1, 2, and 3, those two sets are not the same because one actually has one element extra, that is not found in the other one. And because these two sets are different, then we cannot say that 1, 2 is the same as the set 1, 2, 3, and as a result, the set 1, 2 is not an element. It cannot be found in this particular set here. Alright, so in the text channel, that is true. Okay, so let me just kind of repeat that in the notes here. That is also false. Now, the question is, why is it false? It is false not because the set of 1, 2 is not the same as the set of 1, 2, 3. It really has to do with the set 1, 2 is not 1. The set of 1, 2 is not 2. The set 1, 2 is not 3 either. So for each element in the set, okay, for each element on the right hand side of the element of operator, if we take each one and compare that to whatever value is being specified on the left hand side, they do not equal. And as a result, we cannot claim that 1, 2 as a set is an element of the set of 1, 2, 3. Okay, so if I need to really kind of spell this out, it's going to take a little bit of time to type because the set of 1, 2 equals to 1 is false, and the set of 1, 2 is 2 is false, and the set of 1, 2 equals to 3 is also false. Alright, and the example that Mohammed wrote in the text channel is correct. It is indeed true because 1, 2 as a set is an element of the set on the other side of is an element of operator. Yes. So I'm confirming that is the case. But I don't want to type it because it takes really kind of a lot of work to type that. You would not think, it's a lot of work, but every time I type open curly brace, I have to escape it with a backslash. So Luke is asking, the left component of, I'm guessing, of the operator of is an element of has to be at least one set order below the right component for it to have a possibility to come out true. Yes. It doesn't automatically make it true, but in order for it even to have a chance of being true, yes, you need the level of parentheses to be one fewer than the one on the right hand side. That is correct. Alright, so I'm waiting for Nathan to finish typing and then I'll answer that question too. Implication. Not exactly understanding the context of why implication is mentioned. It is not an implication. it is, well, okay, it's a reverse implication. You can say that if the left hand side has the same or more levels of curly braces than the right hand side, then there's no chance that the is an element of is going to be true. So you can say the reverse, but you cannot say the positive, where you can say, if the left hand side has fewer levels of braces, then it has to be an element of the right hand side. So we have to be careful with implication, because it depends on what is implying what, right? And it is not clear when we just say, oh, there's an implication here. Well, sort of, depending on the polarity of what is on the left hand side and what is on the right hand side. All right, so Mohammed is still typing. I'm gonna wait a little bit. Equivalency versus element sets. Yep, there are two different things as illustrated here. So we can see that there's equivalency here, but when we look at element of, it is false. Yep. All right. Okay, so I'm going to include a little bit of stuff here. Okay. Equals versus in. That is where the extra curly braces come in. Right. So if the left hand side has some levels of braces, then that has to be contained in an extra pair of braces on the right hand side in order for the it's an element of operator to return true. There we go. Yep. All right, so at this point, I'm going to at least relate this to a certain construct in JavaScript programming, because I don't want this class to be super duper dry, even though it is supposed to be super duper dry. But I do want to kind of mention something in JavaScript. So in JavaScript, you can create objects. Okay, an object is created just by using curly braces. So if you use braces, as the beginning, as the end, also at the end, then you're defining an object, and then within an object you can have members. And members are fairly easy to understand. You have A as a member in this case, and then you can define B also as a member. And then each member needs to have a value, so you can say the value is undefined. I mean, that's perfectly okay. Undefined is actually a very specifically defined value, but it is called undefined. Okay, so yes, I'm just kind of playing with that name here. Yep, sort of. But you can also define something else as an object. So C over here can be a nested object, right? So C is an object, and then within C you can now contain any member. It can be empty. Okay, an object can be empty where it has no members, but C can contain a member called A again. So the value of the member is not important here, and that's why they're all undefined. Undefined. There we go. And it also can contain any member that is the member name doesn't really matter. So in this case, we have a set. Okay, the top level set has 3 members, and then the third member that has a name of C is also a set where it has 2 members in this case. Now, the one thing I want to mention here is in JavaScript, they actually have an operator to iterate through the members of an object. So let me kind of illustrate it here. So if I just say this is a variable, I called it S for set. Okay, so let's say this is a set. Then you can actually use a for loop, and then you can say for, and then you can say let or const, and whatever you want to do. So I'm going to say const e, and let's see, in. Okay, so you have to use in because it is a member in an object. So you can do this, and then you can do something with member E of variable S. There we go. So even though I'm not even using the set type in JavaScript, the concept of an object in JavaScript is kind of like a set, because with the only exception that everything, all the members within a set, they all need to be named. So A is named, B is named, and then C, which is an object by itself, also need to be named. So this way we can designate, okay, which member do you want to refer to? So that's how we can go through. That's how we can define membership within an object, which is kind of like a set. And this is the control structure that we can use to go through all the members within an object in JavaScript. So I just kind of want to mention it because JavaScript is a useful programming language, as I kind of mentioned shortly before the class started today. And a lot of algorithms that need to make use of the concept of a set can be, depending on whether things are nested or not, they can be implemented rather easily in JavaScript. And as you can also see here, because S is actually an object, JavaScript is not strongly typed. When you create an object, it doesn't have to belong to a class. So this is just an object that I'm creating on the fly, and I can add or delete members as the program goes in runtime. Yep, object is literal, and functions are literals too in JavaScript. Yep, so Chandra is correct. Objects are literals, and so are functions, which makes it kind of flexible compared to C and C++, because in C and C++, passing a function to another function is a pain, but doing it in JavaScript is like snap, easy. Alright, so Chris is asking, are the two A's two different things, or are they the same thing? Well, it depends on what you're talking about, because if you're referring to the name of a member, they are the same thing. They are the same name, but they can contain different values. In other words, if I don't want this part to be undefined, I can define member A of S to be, okay, let's just do it, okay? Now this is beyond set notation, because in set notation, okay, so set and maps are related concepts in programming. A set is basically just a bunch of things, but there's nothing associated with each thing. A map, on the other hand, is mapping a thing to another value. Okay, it's basically a what they call a KV pair, a key value pair. So in this case, this A can be a value of 2. It's kind of faint, unfortunately, because of the syntax highlighting and the dark theme that I have chosen. I can turn off the dark theme, by the way, right here. There we go. Nice. Yeah, go ahead. I can't. It's kind of choppy. Okay. No, it's not you. I think it's Mariam. Oh, okay. Uh, oh, okay. I see. Gotcha. All right. All right. So getting back to the example. So in the concept of an object, it's more like a map. So A is the name of a member, but 2 is the value of that particular member. So basically it's a KV pair where A is the key and then 2 is the value. So when you look at member A of member C of the variable S, it has a value of 3, but when you look at member A of S, it has a value of 2. And that is not a concept of a set. It is a concept of a map where each item in a set has a corresponding value associated with it. So that's a little bit different compared to what we are talking about. Is that okay? But the concept is, if you just look at variable s, it only has three members. But one of the members of the three of s, member c to be specific, it also has two members on its own. So in a way, it is kind of like a set where there's a subset within the set itself. Well, I shouldn't say subset. There's a set as a member of the other set. That would be a better way to put it. All right. So I'm not sure whether this is, making it more confusing or not, but I would like to think that, I have mentioned that the concept of a set is really useful and it can be directly used in some scripting languages. And then Chris is typing something. Alrighty. Alright, section 4, I think we talked about it already, whether a set can be an element of another set or not. So we talked about that already. So it really boils down to equality. Basically, you're trying to see if the item, the value on the left-hand side of is an element of can be matched, can be considered equal to one of the things within the braces of the thing that is on the right hand side. So it really boils down to equality in the end. Alright, section 5 is interesting because now we are talking about things or sets that have an infinite number of elements. So in this class we deal with integers a lot. Okay, we don't deal with real numbers for one reason, because real numbers are not discrete. Yeah, you can say real numbers are indiscrete, but that's not the right context of the word discrete. So discrete in the sense of this class is the same thing as countable. Okay, yeah, we'll get to that concept later on, but countable is a kind of interesting concept. With integers, they're countable, even though you can extend the number lines on both ends to no end. There's no end to the number line on either side, but you can count, right? Because you can say, oh, we can start with this. This is 0, this is 1, this is 2, this is 3, and so on. And then on the opposite side, we have -1, -2, -3, and so on. So it's countable. Real numbers are not countable. Why? Because there's always a value between two distinct values. So if you look at 1 and 2, you can say, oh, I can easily see there's a 1.5 in between. When you look at 1 and 1.5, you can say there's 1.25 in between. And then when you look at 1 and 1.25, you can say there's 1.125 in between. So as long as you're talking about two different real values, you cannot say how many things are in between. On the other hand, if you give me one integer and you give me another integer and they are not the same, I can always tell you exactly how many integers are in between. That is the main difference between discrete versus non-discrete math. And in this class, we only deal with discrete stuff. Okay, so for the most part, we deal with integers and natural numbers and stuff like that. We do not deal with continuous stuff like what you have learned in your calculus classes. So I just wanted to make it clear, so this way, we kind of, get that out of the way. All right, so getting back to this question here. If I want to have a set E to express well, this is the set that contains all the even numbers. Okay, in other words, I want to express that I have a set of even numbers, even integers. Okay, if you want to be more specific, the question is, how am I going to denote that? Well, one way to kind of denote that is to show by example like this, but that really is a really poor way to say that E is a set of even numbers, because we really don't know what is going before the -4. Maybe it's -8, right? Because we may be looking at positive and negative powers of 2, but then it doesn't make sense because 0 is not a power of 2, right? So we don't really know for sure, what is over here on the left hand side of the -4, or what is on the right hand side of the 4. It's one way that you can sort of illustrate, what you want the set to contain, but at the same time, it's really not a very good way to say it. So we're going to introduce a new terminology here. So now we're going to introduce this terminology, or this symbol, I should say. This is a notation. We're introducing this notation here, where we say E is a set. Now we know E is a set because of the braces, but how do we know what are the membership of the set? So we say we know each member, each member X of the set E is has to meet the following requirements. So the following requirement is X has to be an integer. So Z, or what looks like Z here, is the set of all integers. So we are saying X is an integer. This is AND. Now, how do we know this is AND? This little inverted V symbol, how do we know this is actually saying the same thing as ampersand ampersand in C++? We talked about that last Wednesday. Okay, so for people who are thinking, I have no idea what this symbol is representing, this is a wake-up call to tell you that it is important to review your notes after a class. Now, I certainly hope that no one in this class is thinking that right now, but if there's anyone thinking like that right now, it's not too bad. Okay, it's simply, me telling you and saying that, okay, it's a good idea to review your notes, okay, to know how the symbols are defined. Alright, so moving on, this is x mod 2 equals to 0. Okay, so we need, in order for the conjunction itself to be true, in order to qualify as a member of the set E, we need the conjunction itself to be true. So we are looking at an integer, but we also want the integer mod 2 to be 0. Do you guys remember what mod is? What is x mod 2? What is another way to describe x mod 2? Right, so mod is the remainder of a division. So if x mod 2 equals to 0, it means when you divide x by 2, it has a remainder of 0, which is one way to check whether a value, an integer, is even or not. Yep, it is in a remainder. All right, excellent. So this is how we can check membership. And this is also how we can express a set that has an infinite number of members. Okay, so in other words, there's no way I can enumerate and list every single member of this set, but I can describe what it takes to qualify to become a member of this set. Now, it really is a two-way thing. It is an if and only if thing, which means anything that meets this requirement has to be a member of E, but it also says the opposite, which is every member of E has to meet this requirement. Does everybody understand, the importance of if and only if here? Because if I say just if or only if, going in one direction, it is not the same as saying, if and only if in this context. Oh, okay, I'll say that again. Let's see. I need to remember to take roll. I need to give you guys the extra time, but all right. So let me. Okay, I'm just thinking what I should do here. Okay, so we can go for this kind of shorthand here. Okay, and I'll explain it using the shorthand. So when we use this notation, which is E equals to X and then a vertical bar, which is you can say as such that, right? And then P of X is, you can look at P as what we call a predicate. And obviously, I have not explained what a predicate is, but a predicate is basically a function that returns either true or false. Okay, so X is an argument that we pass to a function, and then the function P has to return either true or false. So in this case, if I use this notation, it is saying exactly the same thing as the following. Okay, so this statement here is the same as this statement here in terms of the meaning. So what that means is E is a set where each member X has to meet the requirement of P of X is saying exactly the same thing as x is a member of E if and only if P of x is true. So if I don't say is true, it means automatically it is in uh, it means automatically that we are comparing it to true. Bidirectional condition. It's basically going either way. We defined this operator last Wednesday as well, right? It is if and only if. It's basically A if and only if B means A implies B and B implies A. So if one side is true, the other side has to be true symmetrically. And then if one side is false, then the other side also has to be false, also symmetrically. Alrighty. Alright, so my watch buzzed, but I forgot to take roll. So I'm gonna take roll now. And the word for today's roll taking activity is union. We didn't quite get to the operator yet, union. You cannot see the activity yet. Let me go back to the activity and then give you guys 10 minutes to do it. And it is for today. Today is the 24th. There we go. And I will give you guys enough time to do it. So the time right now is 05. I'll give you 10 minutes. So 05 plus 11 is 16 p.m. Right, there we go. And now I need to save and publish. There we go. Alright, so now it is published. And go ahead, and I'm going to type the word for roll taking. It's just union, U-N-I-O-N. As you guys are typing, I'm looking at Chris's question. So x such that k is in z, and then the comma is probably a conjunction, right? X equals to 2k is also the same way to define E. Yes, that would be the same. Now, in this case, it does introduce, k as an unbound variable, which is okay. Okay, it's not a problem. It's just that in order to explain the definition in Chris's explanation of a set of even numbers, then you have to say k is for every k in z, or k is an element of z. So you can also look at it the other way. You can say x divided by 2 has to be in z. That's the other way to define it too. Alright. So Mariam probably copied the wrong word or typed in the wrong word. It's okay. I'm gonna go fix it for you. Yep, case and white space does matter. Nope, it's just, all over. Oh, okay. Well, I can check and find out exactly what Mariam put in, but that's not important. I'm gonna count it in because obviously Mariam is participating. Yep, not a problem. Alright, so moving on, back to the notes. Back to more concepts. Alright. Okay, now I'm curious. Now I'm curious of what people actually put in to get it wrong. So okay, so if you're gonna put it wrong, I'm gonna go check it manually, and then I'll tell you why you got quote unquote you got it wrong. Okay, I'll still give you the point, but personally, I'm just kind of curious. Is it a space? Is it what made Canvas count your answer wrong? So that's just a curiosity thing. It's not a criticism kind of thing. All right. So I'll be okay with this notation here. So when we use this notation, E equals to a set, each element x such that p of x is true, is really saying exactly the same thing as x is in E if and only if p of x. So that means, okay, so let me just kind of give you the four possibilities. If I know that x is indeed is in E, that means P of x has to be true. That's one. If I know P of x is true, then I know x has to be in E, okay, because it's going in both directions. On the other hand, if I know a particular value is not in E, the set E, that means P of x has to be false, because if one side is false, the other side has to be false. But it's not going only in one direction, it's also going in the opposite direction, which means if I know P of x is false to begin with, then I know for sure that x is in E is also false, which means x is not in E. So that is what if and only if, why it is useful, because it goes in both directions. And it also applies to what if we know one side is true, then the other side has to be true. If I know one side is false, then the other side also has to be false. Alrighty. Oh, okay. Huh. I thought I only opened up one, so you can actually participate. Maybe I got it wrong. Uh, that's still visible, right? And has no due date. That one has no due date. So maybe. Oh, okay. Well, let's see. There's still enough time for people to go back and do the right one. Oh, they got it? Okay, excellent. All right, cool. Thank you for the clarification. I have to hide stuff that is not relevant. I hid most of them, just except for that one. All right. So, do we have any questions about the notation here? About, how we can describe a set that has an infinite number of elements, and we can only describe the property of what it takes to be a member of a set. Yeah, go ahead. Mm-hmm. That's the mathematical notation. Uh-huh. The if and only if is referring to this. If and only if here. So, mm-hmm. No. Okay, so the if and only if applies to membership. X is an element of E if and only if, and then this part here, still has the and. So this and is still corresponding to this and operator here. Yep. So the if and only if is basically specifying there's a condition over here that describes the membership, but I want to know whether it is how strict is this membership. Are we saying that everything that meets this requirement is automatically a member of E and only that? Because in that case, I can have additional members in E. Or am I saying that every element in E has to satisfy this requirement only? Because in that case, it can contain not every even number has to be in E, because I'm saying just the opposite. Every element in E has to satisfy this requirement. So E can, for all we know, can only contain 2 and 6, right? Which is not really the set of all the even numbers, but nonetheless, every single element of E meets the requirement. So that's why I have to specify if and only if here to basically say if you meet this requirement, you are automatically a member of E. At the same time, if you are a member of E, you also automatically means that you have met this requirement. It's Yeah, so that's the thing is, so when you look at this notation, it does not mention anything about if and only if whatsoever. But when you look at the equivalent form of this notation, it does contain the if and only if. Now, in terms of how mathematicians express, what a particular set contains, they like to use this notation, the notation that I am hovering my mouse pointer over, even though, yeah, exactly, that's just a convention. They could have used this notation too, except the second form is usually not the one that they choose to use. They choose to use the first one, but they mean yeah, they just mean exactly the same thing. The second one spells out what it means better, but the first one is preferred by mathematicians when they want to tell people what is inside a particular set or how they define a particular set. Alrighty, we have 5 more minutes, so we are moving on. So section 6 talks about a set that has no elements, which is equivalent to, guess what? An empty folder, a folder that has no files nor subfolders. So there are different notations. One notation is kind of like a circle with a stroke across it. I find that one to be a little confusing because some people look at it and think it is phi, the Greek symbol, and other people look at it and say that's 0 because it has a stroke in between through the circle. So I'm just using the most intuitive notation, which is open and close brace right there. Okay, so okay, very good. Okay, I like Mohammed's thinking, because he's already thinking about some really good questions to ask. All right, so I'm getting back to my own notes here, and I'm going to continue with some more questions. So the question is, all right, so focus on this part here. So what is the answer? Is it true or is it false? Yep. Oh. I just pressed keys in the wrong window and it opened up a new window for me because I intended to get back to my text editor here. Alright, so this is true, and I know we have done this already, but we are gonna try to answer this question here. What about this? Yep, it is false indeed. And just one more thing. What about this? It is also false. That's right. Okay, so that means, okay, so let me just make one point really clear. This is very, very explicit. There we go. Is that okay? The set that contains an empty set is not empty. Just like you can create a folder that contains a subfolder, but that subfolder is empty. But at the top level folder is not empty. It does contain one item, which is the subfolder, but the subfolder itself may not have anything in it. So that's really kind of important. So these are all very important concept questions. So I really like how Mohammed is thinking about these additional questions. Just by looking at one concept, he is already kind of linking it to some of the other concepts that we have talked about already, and start to go like, okay, how does this connect with blah blah blah? Okay, all the things that we have talked about, and that really is it's really a skill that is developed. Okay, this is a learned skill. So if Mohammed can share with the rest of the class, if he wants to, or if anyone wants to, you can go to the study skills text channel and share with the rest of the class how you learned to think like this, because this is very, very effective when you are dealing with a STEM subject matter. DOS would not let you delete a folder that is non-empty. Yep. And on the command line, I think it still does not let you do it. It's just that using the GUI, you can just click on the thing and then just press the delete key. All right, so let me take a look at the time. We got 1 minute and a half. Okay, so we still have x such that x is not an element of x. Okay, so that would include everything under the sun, Chris. Okay, let me specify what I mean by that. Um, it is not. I'm not sure. Okay, so I'm not sure whether this is a paradox or not. But in most literature, so if x is a set, then x is an element of itself is automatically false. So I'm not sure whether it's a paradox or not, because it's. I think this is how it's like an axiom, where they say if x is a set, then x is an element of itself is automatically false. So that means, when you have that statement, x such that x is not an element of itself, it is including every possible set that you can create with, which is just immense, right? I mean, that's like a lot of things. All right, so I can look it up, Russell's paradox, and look it up and study a little bit more. The set of all sets that aren't members of themselves. Okay, I will look it up. But I can assure you that we are not going to encounter those situations in this class. Alright, so we are running out of time, so I am going to stop here, which means the rest of the class, we really should be reading ahead. So finish up the reading of this entire module and start with the next one. In other words, we are definitely going to get into quantifiers on Wednesday, and then we will be using quantifiers to revisit, all of these operators here, which is intersection, union, difference, and so on. So it's really important to not only to go over what we have covered up to this point, but also to read ahead a little bit. All right, so I am done with the lecture. Are there any questions before I stop the screen capture? Post notes. Oh, you mean this stuff over here? Oh, that's okay. I can show you how to do that. Joplin is using Markdown, and this is Markdown. So the in operator, so in order to do a math equation, you have to start with a dollar sign and end with a dollar sign. So anything within dollar sign and dollar sign is interpreted as a LaTeX notation for math equations. So in, or the little funny looking E operator, is just backslash and then IN. Now the other way you can do this, okay, this is a really nifty trick if you want to learn how to do it, is to look at anything that I have typed here and then just do a right click, go to show math as, and then use the tech commands. So this will show you exactly how it is typed, and then in Joplin or any type of markdown, you just have to start with a dollar sign and end with a dollar sign, and that basically it should appear as it appears in the notes. So that should do it. Yep, okay, cool. Alright, so getting back to me posting the notes, do you guys want me to post it in Markdown, or do you want me to post it in HTML, or do you want me to post it in PDF? Please no, all of the above. Our first assignment is going to be next. I will assign it on Wednesday because we need to go over all of the intersection, union, and other operators first. So that's when we're going to do it. PDFs. You guys want PDFs? Why would you want PDFs? PDF is lame. Because you can. Okay, I would think that most people want the source, right? The markdown version of everything, because now you can use Joplin. I mean, you can literally copy and paste this stuff into Joplin, and it will show just correctly in Joplin, because this is just regular markdown, and Joplin can recognize a little bit more than just regular markdown. Um, Bitstream. All right, I'll do PDF. But okay, fine. Yep, on multiple devices, Markdown is the best. You can just translate Markdown into any format you want. Okay, I'm gonna mention this tool, for those of you who are um, uh, interested. It's called Pandoc. Okay, so Pandoc is a tool to translate or convert from one format to another. So it can handle all the lightweight stuff, heavy duty stuff, and everything in between. It's a really kind of nifty tool. It's very expandable as well, so you can actually add additional filters. It can do all kinds of fun stuff with Pandoc. So it's a tool. Go ahead, and if you are interested, go ahead and play with it, download it. But for today's lecture, I am just gonna do the PDF. Okay, where did that go? Oh no, did I close it? No, I cannot possibly have closed it. All right, so never mind. I'm gonna go find it and then post it in the text channel. Anything else? Anything else before I close the? Oh, right, before it's just kind of scrolled off the other side. Alrighty, so I can just print this page into PDF and then post that. There we go. So print as PDF, and it's gonna ask me where they want to save it. I don't know why. I can change the. Alright, so I'm gonna post that. Anything else? How to do the voice to board. Okay, contact Orinit. Okay, so I'm gonna post her email here. limano@arc.lowesrios.edu. So contact her. She is our college president of the union, of the teachers union, and she is organizing. Yeah, go ahead and email her. Just let her know that you are in my class. Because I'm a union rep, she knows me. Just let her know that you're in my class and you are interested in voicing your opinion. And the more people, the better. Each person has 3 minutes to kind of voice your piece, and Orient will be able to tell you approximately what time you should sign into the Zoom meeting, in order to have a chance to not have a chance. You will be given a chance to speak up, to let people know about how you feel about the decision to get rid of all the math classes at or below Algebra 2. It's happening today. So this is all happening today. And I think already estimates about 4 p.m. is when people can start to voice their opinion. But the time is flexible. It really kind of depends on the meeting itself. But Aurelie will give you the link. She'll give you kind of the time and also give you some idea of how to organize your speech. Yep. Yeah, it started this morning. It started at 9 a.m. I believe. Okay, thank you, Miriam. Yeah, so it's a really long meeting, but they won't be hearing public opinion until about 4 p.m. And then Aurelie will be able to help you with telling you when to sign in and kind of just approximately what to do, what to say, that sort of thing. But I do appreciate your help, okay, to kind of help us, help your professors to maintain classes that we think, some people really need. This is how we get people to the jobs that they want to get into. So I think that's important. All right, so I'm pretty much done with the lecture. Anything else before I close the live stream? Oh, right, post the PDF. Forgot about that. Yep, I made everything and then I forget to actually post it. There we go. Alright, so that's the notes for today as PDF, as requested. Anything else? If there's nothing else, I'm gonna close the at least the live the voice session. Okay, well, you guys are all welcome. Thank you. Alrighty, so I'll see you guys on Wednesday. Oh no, the assignment is gonna do in a week, so you guys would get plenty of time to kind of ponder and think about it. Yeah, you got a week to do it. All right, cool. See you guys on Wednesday. And thank you for those of you who volunteered to kind of voice your opinion later on in the afternoon. So thank you for that, for doing that. Cool. Name again? Oranite. 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 There you go. There's no assignment at this point. The assignment will be assigned on Wednesday, and you will have a week to do it. Mm-hmm. Alrighty. So I'm gonna sign off from the voice channel, but I'll be keeping. Go ahead. Absolutely. Yep. I think the markdown version is it's good from the perspective of you can actually do anything with the markdown version. Oh, okay. Yeah, Obsidian is the same because Markdown is Markdown. All the Markdown formats share a really good portion of common features. And what I did today, the features that I used today is pretty standard. So I would be very surprised if it doesn't work. Yeah, well, some actually has some extensions, especially when you use tables. There's a mm-hmm. Yeah, because with tables, some extensions can merge columns in a cell, which can be very handy, depending on what kind of table you're creating. In this class, sometimes I wish the standard Markdown can merge cells just horizontally across columns. I don't really need to merge across rows, but I need to merge across columns. The standard Markdown does not support that, but there's an extension of Markdown that does. And then the other extension is called Mermaid. Mermaid is an extension that allows you to type text and it will turn it into a graph. That comes in very handy as well. It's a really cool extension. The first one is, I think it's called multi-table, if I remember correctly. I could be wrong, but it's a multi-table and Mermaid. Yep, I think that is correct, but I'm not 100%. Yeah, and then some can also support a TOC, table of contents. So if you just put in open square bracket TOC close square bracket, it will automatically put in a table of contents. It's only useful if you have a lot of stuff, like if you have. Mhm. Mhm. Yep, and then you can also put in raw HTML elements. So if you know how to do divs and you can float things around, you can actually put in raw HTML divs with all the CSS styling. And mhm. Yeah, it's really useful when you're reviewing your notes because when you're reviewing your notes, you might want your summary to stand out within a block of text that you logged during the lecture. So you can just put a box, put a border around a div, and and use all kinds of highlighting backgrounds and whatnot. And so there's no limit, because HTML, can be used. There's no limit of what you can do to format your stuff in Markdown. All right. You're welcome. Yeah, so Mohammed, that looks right. Okay, that's good. Yeah, Orion is really friendly. She'll be more than happy to work with you. And it's really your voice. I mean, so as long as oh, okay. So as long as that's what you want to come across and let the board of governors know, it's all good. As long as you're authentic and that's exactly what you want to say, there's nothing wrong that you can say in that meeting. All right. Okay, so Chris puts in a question in the general text channel. I'm gonna respond in the text channel, so because I don't want to hog the voice channel any further. So I'm gonna move all the traffic, all the discussions into the text channel from now on. So I'll see you guys on Wednesday.